Hey guys, so this is me re-recording the audio to our test review. I guess I didn't do a good job with the audio before. That happens when I'm writing on the side to the computer. So I'm just going to kind of give you guys the directions as we go. So I'm just going to kind of do this as I'm writing. I'll just kind of let you know what I'm thinking here. All right. So for this first problem, you've got y equals -2 times the sine, or 2 times the sine of x. A couple things to keep in mind. It's a sine wave, so it has a specific behavior. We do want to first probably go find the period. It's going to go out 4 marks to find the period on the graph either way. So when you're looking at the test and you're seeing the graphs, that 4th mark is where we're going to find the period. And then whatever number's out here in front, this is going to be the amplitude. And so that tells me how high and low the graph goes. I'm going to go up to +2, down to -2. Now, if there's like a +3 at the end of the problem, then the whole thing gets shifted up 3. But in a problem like this, it's just going to be -2 to 2. Now, sine waves always start in the center of the graph, and traditionally they go up to their positive amplitude. But because this one is -2, it is first going to go downward to -2. Then its next dot's going to take it back to the center. Then we'll go to the opposite amplitude, whatever that is. So because we went to -2 first, now we're +2, and then we return back to the center. We'll reverse that as we're going to go ahead and create the curve there. We would reverse that as we go back to the left. As you go left, you'd go up first, and then down, and so you'll see I'm going to go ahead and finish off the graph to the left by putting in those extra dots. On the test, you're going to see a graph and be asked to find the equation. So knowing that this thing goes straight through the center, the origin, tells me it's a sine wave, and that's important for narrowing down my choices. But we still have to find the period to figure out which, what is the perfect scenario there. And it's always 2 pi over whatever's multiplied by x. In this problem, there isn't a number next to x, so we default to 1. So real quick, as we're looking at this, we would expect that the 4th mark out, we would be at 2 pi. If you think about pi being 3.14, it's 6.28. I think in the graphs, you'll see it's very clear. But knowing what the period is critical. You're going to see almost the identical problem here with question number 2. This one's +2 cosine, so it's still 2 up and 2 down. Cosine doesn't start in the center. It starts at its amplitude. And because this is a positive amplitude, it'll start at +2. If it was a -2 cosine, it would start at -2. And then the next dot will be center, then the opposite amplitude again, back to center, and then back to where it had started. We always end where we start. And so you start to see that curve there. So cosine, it's really not different than sine other than where it's starting. Instead of starting at the center, it starts at the amplitude. In fact, if you line them up next to each other, it's literally a 1 hash mark shift. So it's not much of a difference between them. And we know that a cosine doesn't cross through the center. I mean, that's kind of where we're at there. The formula for period is the same thing. To find the period, it's going to be 2 pi divided by the number times x. Looks like I had to pause the video for some reason the first time through, moving stuff around. Maybe I was looking for a little bit more light. But in this case, the period would just be, what am I doing? There you go, 2 pi over, and next to the x, you see it's 2 pi. So that makes it 2 pi over 2 pi. And 2 pi divided by 2 pi comes out to be 1. And so that tells me that the period, or the 4th mark, should be 1. And you should be able to identify that in the pictures. Now we're on to the tangent graph. Now tangent graphs are different. Okay, they don't have the same period. They also have asymptotes, and they don't specifically have an amplitude. But we are still going to go out 4 marks to get to the period. It is negative, which means it's going to trend downward as it goes to the right. It doesn't actually matter how high or low. We're not really worried about that in terms of determining these graphs. Let's see. Next thing we're going to do is, yeah, you'll always have an asymptote at the second mark, and you'll see those in the graphs that you'll look at. The real trick is, what is the period? Now this says it's 2x, so the period for a tangent is not 2 pi over b, it's just regular pi over b. So instead of doing 2 pi divided by 2, it's just pi over 2, and that's what we will label our fourth mark. So it's really important that you're able to identify what the fourth mark is or what it should be for a specific graph. Now that's pi over 2, half of pi, then a fourth of pi is where you'd see that halfway mark. Now tangent curves do go through the center, but because of these asymptotes, it can't continue a wave like you normally would think. And normally it would go from the bottom left up to the top right, but because this one is negative, it's going to go from the top left to the bottom right, and then it will repeat that same curve over and over again. Right here you see I'm kind of putting that dot. The negative 1 in front of the tangent means that at the first mark, that's how far down I would be, is at negative 1. That's not going to be super critical to how comfortable you feel with it. Really, this is going to be is it positive or negative, meaning does it go up as it goes to the right or down as it goes to the right? And then the other is, where is that fourth mark, if you will? And you'll notice at the fourth mark, the repeat of our tangent curve, the repeat of it is touching the x-axis at that mark there. You kind of see it right here. Okay, that fourth mark, you should see the tangent curve coming back through, and that's a good way to indicate where is the period or the fourth mark. Okay, you'll see it's just a repeat over and over again, but that fourth mark right there is going to be really, really helpful there. All right. With these last three, it's really about using those identities that you should have and the worksheet that you have that helps you do some substitutions. It's all about replacing information to make the most use of what's in front of you, to try and simplify it the best you can. If you didn't do the 14.3 worksheet, it's going to be hard to come up with all the intuition that you need, but maybe this video will help you enough. Looks like maybe I paused the video again. Just waiting for Mr. Welch to start working here. But if you have that trig identity worksheet with all those identities written up at the top, you should have definition for cotangent, that is cosine over sine. And the tangent definition is sine over cosine. Now there is more than one definition for cotangent and tangent. This is the one that I think is the most direct. Whenever you have a fraction over fraction, we're going to flip in times. So instead of having it divided, we're going to times by cosine over sine, which would give me cosine squared over sine squared. Now, that normally we'd look for, does that do something? Is there some cancellation? In this case, there isn't. But I do know that cosine over sine is cotangent, so cosine squared over sine squared would be cotangent squared. It's about identities and substitutions. This one's going to be very direct. You'll see something very similar on the test. Really, we want to turn everything into sines and cosines the best we can. And tangent is defined as sine over cosine. Well, sine is already a sine, but I will put it over 1. And then cosine is also just a cosine. I'll put it over 1. The key here is to recognize that you have a cancellation from top to bottom. Now, those sines do not cancel, and so a sine times a sine is a sine squared. Okay? Now, sometimes they will cancel. If everything canceled, you get a 1, but that's not always that common. That was supposed to be an x. Whatever you use. I think I use an x on the computer, so just put an x in there for your variable. Here we have a little bit of a tricky thing because we have sine times cosecant, but that plus tangent squared should make you think of Pythagorean, some sort of Pythagorean identity, and there will be something like that on the test. With this multiplication between sine and cosecant, we think maybe going along the words of sine, we could cancel some stuff, and cosecant is 1 over sine based on our definitions. Well, a sine times 1 over sine, that should cancel and leave me with just a 1 plus my tangent squared that I never touched. In the Pythagorean identities, there is a formula that says, see, if he doesn't stop it, if I don't show you the identity, I might pause it. And yeah, here we go. If we go back and look at the trig identities that hopefully you have on the worksheet from last week, let's scroll up here. And again, this worksheet's one that you get to use during the test. Right here, it has secant squared minus tangent squared equals 1. And I don't know if I'll show it to you, but right here, if you were to add the tangent squared over to the right side, that secant squared would be alone. But that secant squared would be equal to 1 plus tangent squared. And since that's what I have right here, 1 plus tangent squared, I can say that this is equal to the secant squared of x. Will they all be squared? No, that's not a realistic deal. That's probably not that common. Hopefully this audio is enough to kind of get you over the hump. If it's not, give me a call on Teams or email me and tell me you want to set up an appointment to discuss the test review or testing. If you haven't already taken the test, guys, we need to get it done so we can talk about your grade, so you can move forward. I'm happy to go through things with you and go talk about your grade individually, but let's make the best out of a tough situation. Obviously, next year is going to be a different year because there's going to be some things that you're missing, or there's going to be some things that are just different, maybe more challenging. I'm here for you. I'll be there for you. I'm going to do everything I can to support you, but you do have to talk. You got to say, I need the help. Yeah. First, you have an addiction to being bad at math. First step is to admit that you have a problem. And so, let me help you. Good luck, guys. Hope the test goes well. And yeah, we'll see you hopefully soon.